Jai Hind students. Today we are going to continue the chapter 1 and in today lecture we will discuss about the components of computer. So students, let me first do the full screen. So in this components of computer, so basically this entire computer system is made up of three components. That is the one CPU as you see in the middle, that is called the central processing unit, and the input unit, which comprises of the input devices, that is your keyboard, a mouse, a scanner, and the third one is the output unit, which comprises of the output devices. So students, through these input devices we provide the data, means instructions, to the processor for processing on the data, to convert the data into the information. Now this information displayed to the user through the output devices, maybe that output devices a monitor which you are seeing at present on your mobile screen or your laptop screen, or this output can be a speaker, this output can be a printer also. So these output devices are used to show the processed data. After processing the data, the processed data means information, to show the information to the user on computer screen or in the print form. And after that you see this is a storage unit. So basically all this data, after processing, sometimes it is stored in the memory of a computer. So this is the main memory, or you can say the internal memory, the cache, or the RAM. Now see the CPU in detail. The CPU, this central processing unit, is also called the brain of the computer, students. It controls the operation of all the components of a computer. Means it do the arithmetic and logical operations, it do the accessing the data from the memory, and also stores the data in the memory. So here you can see the bidirectional arrow, means the control unit gives the instructions or data to the ALU to perform the arithmetic and logical operations, and the result again given back by the ALU unit to the control unit. Now the control unit again takes the decisions what to do with the result, whether it is to store in the memory or to give to the output unit. Now see, the CPU itself has the three components just now I have shown you: control unit, arithmetic logic unit, and the memory or storage unit. So control unit is the brain of the CPU. All brain of the CPU means it controls the all actions of the computer. This control unit only do. So this CU executes the instructions and manages the flow of data inside the CPU. So the instructions executed by this control unit first only. So it fetches the instructions from the instruction register. A register is the memory inside the CPU in which the instructions are stored. So this instructions executed by the control unit, and according to the instructions it sends the data to the respective unit. So it manages the flow of data inside the CPU to perform the task specified by a computer program. So if the instruction is to print it, so this control unit will give the data to the printer for printing. It plays a pivotal role in the fetch, decode, execute cycle. So what does control unit does? It fetch the instruction. Fetch, decode, execute means it fetch the instruction from the instruction register, and this instruction register student is the memory. And after that it will decode the instruction, means it find out the meaning of the instructions, what to do with that a command. And third is execute cycle, and after decoding the instructions it gives to the corresponding unit of a computer to execute the instructions, which is a fundamental process by which a CPU runs the program instructions. So see the functions of the control unit. First it instruction fetch. So first what the control unit does, it fetches the instructions to run and execute a program. So control unit fetch the instructions from the RAM, random access memory. So from the RAM, the data or instruction goes to the cache memory, from cache to the instruction register. And registers are the fastest memory which is very close to the CPU. Next is the instruction decoding. So it decodes the fetched instructions to determine the operation to be performed. And after that, instruction execution. So this control unit students execute the instructions by sending the control signals to the appropriate functional unit within the CPU. If it is for the arithmetic and logical operations, so it gives the control signals to the ALU unit, and after that it manages the control flow. That is the control flow management. Students, control unit is responsible for overseeing the control flow of the program. It accomplishes this by updating the program counter, which enables the CPU to go to the subsequent instructions in the sequence based on conditional statements or jumps. So in this control flow management, it do the entire control the entire flow of the program. It do the task by updating the program counter, and this helps the CPU to go to the subsequent instructions in the sequence based on the additional statements or jumps. So means it fetch the instructions from the cache memory and store it in the instruction registers, and when the present instructions executed, again the control units prefetch the instructions from the cache memory to the instruction registers. Next is the exception handling. So this system effectively manages the exceptions and interruptions, including hardware failures, system calls, and external events by appropriately diverting the control flow of the CPU to the planned procedure for managing such exceptions. So this exception handling is also does by the control unit CPU. So if any time interruption generated, means suppose you have wants to close a program during watching a movie, you wants to close a program. So when you generate the event to the mouse, that is called the interruptions. Sometimes your hardware fails. So that is also the interruptions, and this is handled by this control unit. Sometimes your computer restart. So this is the exception handling. Next is the pipeline control in the pipeline CPU. The modern CPUs are available with pipeline design. A control unit controls the steps of the pipeline, make sure that the instructions are processed quickly and safely. So in the pipeline control, what is happened? The modern CPUs are available with the pipeline design. So means the instructions to the CPU is given, all instructions are in the pipeline, one by one it provided to the CPU whenever the CPU is free. So means a control unit controls the steps of the pipeline and make sure the instructions are processed quickly and safely. So means here the task of this to provide the instructions to the CPU. Synchronization. So in the context of the multi-core processor, so when the see or nowadays you see them so many quad-core, octa-core processors are there. So basically you can understand the core of the processor means each core of the CPU is working as a CPU only. So means one processor's strength is divided into four parts. Basically you can understand, and each part is capable to do the entire processing work. So this control unit plays a crucial role in facilitating the coordination of the instructions execution across several cores, hence guaranteeing the appropriate synchronizations and maintenance of data consistency. So in synchronization, it do the coordination of the instructions executions across several cores. So to the four cores are there, so four instructions will be provided to the each core, and each and to do the coordination when when any course work is completed, output is completed, so the next instructions will be provided to the data core, hence guaranteeing the appropriate synchronization and maintenance of data consistency. This you can also see, suppose your problem is there, and for your solving the problem, you divide your problem into four parts, and each part needs some calculation, some computation, some arithmetic operations. So each part, four parts you divided, and now each part you given to the each core. Now each core will come up with the result, and after that you will be able to do the operations on the results of the sent by the each core. So that is called the synchronizations. Now the ALU, arithmetic logic unit. So this is a component that has been extensively optimized and engineered to do the multiple tasks concurrent. So this ALU perform more than one task. It is commonly built to execute the operations speedily. So why this ALU is used to do the operations to do the calculation at a fast rate. It works in conjunction with the other CPU components such as registers. Yes. So the values are taken from the registers and the results of two numbers, suppose the ALU is adding, so its result will be stored in the registers only, and that register's name is called the accumulator. So here memory and control units to execute the complex instructions. So means ALU work with the conjunctions with the other CPU components, means registers and memory. Functions of ALU. ALU performs arithmetic operations. It can do the addition, subtraction, multiplication and division. Logical operations. It can perform the logical operation, means uh, comparison of the results of more than one relational operators, that is and or not or, all these are the logical operators. Comparison, so they see what the comparison does, so their results is compared in the logical operations. The ALU can compare two binary values and determine whether they are equal, greater than or less than each other. Now the third unit is students see the memory unit. As you know, so memory or storage unit is the hardware component which is used to store the data and instructions and retrieve it whenever is required. Majorly, computer memory has categorized as the temporary RAM and permanent memory, that is the secondary memory, your hard disk. So RAM is used for short term, fast data access and essential for active program execution. So whatever the data is stored in the RAM, that means is now your that applications, that data you needed, the applications which you are using currently. On the other hand, storage or secondary memory provides permanent data storage. So hence memory and storage units both are critical components of a computer system. So what is the functions of this RAM? Students, you see this RAM is the random access memory. It is also called a temporary memory. At the present time, the PDF which I have opened, so this file is stored in my hard disk also, and this file from the hard disk, it's the copy of it is brought to the RAM also, and the entire file at the one time I'm not showing you on the screen. So it's some part which I'm showing you on the screen, and some more parts is brought to the cache memory, and out of that, at present, how much you are seeing this one page is brought it into the computer's registers. So the content inside the RAM are erased when the power gets off or the systems get restart. So this is why it is also called a volatile memory. So the data in that RAM will remain till where your computer is on, when you are working on the computer. If the power of the computers get off, so the entire data present in the RAM will be erased. RAM is actively used for the program or instruction execution. So this is the image of the RAM which is uh, mounted on the motherboard. So when you open your cabinet of the monitor or CPU, so in that you find the motherboard, and over the motherboard this chip green color you are seeing, that is called the RAM. So once when we start the computer, then the necessary files and programs and the operating systems all are loaded into the RAM for smooth running of the computer. So just when we power on the CPU, so the operating system is stored on the hard disk, that is loaded in the RAM first. And after that, when the operating system loads, then after that, all the execution task is controlled by the operating system. The more RAM a computer has, the better it can handle the multitasking. So if you want to perform more than one task and faster, you need a RAM. Uh, now the storage devices, that is the hard drives, SSD, flash drive, all these are the hard disks. So storage devices are used to store data permanently, even when the computer is powered off. So when you turn off your computer and again after another day you are turning on the computers, you are able to access your file because that files was stored on the This are hard disk or hard drives, and there your data is stored permanently. So at any day or anytime you can access it. They are non-volatile in nature that remains intact even when the power is get off or system restarts. So the most popular and commonly used storage devices are the hard disk, SSD, solid state drive, USB flash drive, the pen drive, optical disk means DVD, CD, all these are. So these are the secondary storage devices, or you can say the permanent storage devices. This is your SSD, hard disk, and this is the pen drive. The data storage capacity varies of these devices are in gigabytes, GB to terabytes and more depending on the type and size of the storage device which you are using it. So this is all for the today students. So in the next class, we will discuss about the input devices and the output devices. So thank you for your attention and cooperation.